All right, guys. In this video, I'm just going over this second little practice test I made up for the students in LS5, and I made it available for everybody. And I've posted the key, but this video is just me going over the questions. Maybe just looking at the key doesn't make sense to you, so maybe watching this video will help you out. So those of you that weren't in LS today, um, or in first period, just some more practice for you. So if you've been struggling on dimensional analysis and, remembering all the metric system stuff, this is just more practice for you. Okay, so if you are struggling with it, I would strongly suggest you try this on your own and then come back and watch the video, um, and see how you did. Or maybe just work through it while you're watching the video. So and just make sure you kind of understand everything that we're doing here. Okay, it'll help you prepare for our VLO test on 1.3 and 1.4 that's coming up. Okay, so the first question here, we have the density of lead reported in grams per milliliter, and we just want to change that to milligrams per decimeter cubed. Okay, so the thing I will say is you have milliliter as a volume measurement unit, and then you have decimeter cubed. They're not the same thing, okay, but this is probably a good time to remember that a decimeter cubed is the same thing as a liter. So if you just want to replace this with a uppercase L, liter, have milligrams per liter, that's the same thing as a decimeter cubed. So really all we got to do is change gram to milligram and milliliter to liter, because again, decimeter cubed is the same thing. All right. So as we look at what we would do, okay, so how do we take a measurement like this and put it in our dimensional analysis setup? The number goes with this unit on our numerator, and then it would be 1 milliliter on the bottom. So this is how we would start it off. So we would say 11.34 grams over 1 milliliter. And again, our goal is to just get grams out of the top here and make it milligrams, and get milliliters out of the bottom here and make it liters. So we got to know that there's 1,000 milligrams in 1 gram. We would put 1 gram on the bottom to cancel out grams and get milligrams on top. And then we also have to know there's 1,000 milliliters in 1 liter. But in this case, we would put 1,000 milliliters on top because we have milliliters on the bottom and we need milliliters to cancel out. And then we'll end up with liters on the bottom. So after we do our math, our numerator unit is milligram, our denominator unit is liter, which is the same thing as decimeter cubed. So it's going to be the same as what we want. So all we have to do is 11.34 times 1,000 times 1,000. And I put it in scientific notation because it's a pretty big number. You don't have to, but we're allowed 4 significant digits here because we started with 4. And remember, metric equalities are infinite sig digs, so they're not limiting us. So 4 sig digs is our answer. And again, if you want to replace this to decimeter cube, that's fine. It's the same thing. Okay. All right, so let's go to the next question. All right, here we got some mole calculations to do. Okay. Remember, formula unit is the same thing as particle. So if formula unit's throwing you off on like where you're trying to go, write the word particle. Okay. But sodium chloride is an ionic compound, and the 1 unit or 1 particle of an ionic compound is called a formula unit. It's not called a molecule. Okay. But that's okay. You can just replace it with the word particle. Okay. So we have 10 grams of sodium chloride. They give us the formula for sodium chloride, and we want to know how many particles of sodium chloride are in this 10-gram sample. So if you're kind of mapping it out, we got to go from grams to moles and then moles to particles. That's what we're going to do, okay? So to go from grams to moles or moles to grams, we need to know the molar mass. In this case, we're going grams to moles. We're going to have to calculate the molar mass of sodium chloride, okay? So this is the formula. That's 1 sodium, 1 chloride. If you go to sodium on the periodic table, it's going to say 22.99 for its molar mass. And chlorine is 35.45 for its molar mass. And you add them, and that's how you get the overall molar mass of this compound. So if we go to the answer here, I take my 10 grams. I say 1 mole over the molar mass that I calculated. Again, 22.99 plus 35.45 adds up to 58.44. Okay. So that'll cancel out grams and get me to moles of the compound. And then we know that there's 1 mole for every Avogadro's number of particles, in this case, formula units. Okay. So we would take our 10 grams divided by the molar mass of the compound, which we calculated as 58.44. And then to convert moles to particles, we multiply by Avogadro's number. That'll cancel out moles and get us to the particles. And so when we do our math, we're going to be limited to 3 sig figs, not because of this and not because of what we started with. That has 4 and that has 4, but Avogadro's number only has 3. So that's why we got to limit it to 3 here. Okay. All right, next question. Okay, they tell us diamond is carbon, and that's all diamond is. It's just carbon atoms. So carbon can take up multiple forms in the solid state. You have graphite, that's just carbon. You got diamond. It depends on the conditions in which the carbon atoms came together. But regardless, we are given a number of carbon atoms. So we have particles of carbon, and we want to know how much that weighs. What mass is that? But we want the mass in this thing called carats. If you haven't heard of a carat, it's a unit of mass that they use for diamonds a lot. And this is not something you'd have to memorize or anything, but you're told that 1 carat is equal to 0.2 grams. So we're going to end up using this equality to convert grams, once we get grams of carbon, to carats. Okay. But the first thing we have to do is go from atoms to moles, and then we'll go from moles to grams. And then once we have grams, we can use this to go from grams to carats. Okay. So again, I'll go back to the answers here. Okay. So we would start with our particles. We would say 1 mole of the element, in this case, carbon on top, for every Avogadro's number of atoms. That'll cancel out atoms or particles and get us 2 moles of carbon. Okay. Then we're going to multiply by the molar mass. So where did we get the 12.01? We went to our periodic table. We looked up carbon. The molar mass of carbon is 12.01. And that's that many grams for every 1 mole. So we're going to put the grams number on top and 1 mole on the bottom to cancel out moles and get to grams. And then we're going to use this ratio, which we get from this equality here. We would put grams on the bottom because that's what we want to cancel out. And we would put 1 carat on top. So for the math, it's going to be our number of particles here divided by Avogadro's number times 12.01 and then divided by 0.2. We're going to have to round to 3 sig figs because we started with 3 here. Avogadro's number has 3, the molar mass is 4, and this ratio has 4 as well. So we're rounding to 3. So it comes out to be a 285 carat diamond, which is a pretty big diamond. Okay. Okay. And so for the last one, the other thing is, for these practice problems, we're doing kind of the more difficult types of problems. You'll see them like the dimensional analysis where you have multiple steps, but it's not always going to be that way. It might just be just one little step that you have to do. Okay. So if we look at this one, number 4, this is a simple problem. Okay. We have grams, we got to go to moles. What are you supposed to do? Grams divided by the molar mass will give you moles, right? That's what we have to do. And so if you knew that and you knew the molar mass of this compound, and you didn't have to show your work, you just do 25 divided by whatever the molar mass of this is, and that's your answer. Okay. But we also want to show our work using dimensional analysis so we can kind of make sure we understand what we're doing. And then I guess the most complicated part of this problem is adding up the molar mass. Okay. So again, eventually at some point this year, you're going to be responsible for, if I give you the name of the compound, you're going to have to be able to come up with this formula. But in the meantime, until then, if I give you a compound and you need to find its molar mass, I'm going to have to give you the formula, but it's going to be up to you. Like, can you interpret this formula so that you can add up all the numbers correctly to get the molar mass? Okay. So we got to be able to look at this and understand that we have 2 aluminums. This 3 gets distributed through the parentheses. So we have 3 times 1 sulfur, and we have 3 times 4 oxygen atoms. Okay. And so we're going to have to go to our periodic table, find aluminum and multiply it by 2, find sulfur and multiply it by 3, and find oxygen and multiply it by 12, and then add them all up, okay, to get the molar mass. But then once we have that molar mass, it's just 25 divided by whatever that molar mass is, and that's going to be our answer, okay? So again, finding the molar mass, it adds up to the molar mass of this compound adds up to 342.14 grams per mole, okay? And again, where did we get these numbers? The 26.98 is the molar mass of aluminum, the 32.06 is the molar mass of sulfur, and the 16 is the molar mass of O, of singular oxygen, right? And so once we have that, now all we do is take our 25 grams, we say 1 mole on top, the molar mass on the bottom, that'll cancel out grams. So 25 divided by 342.14 gives us our answer here. And we have to round to 3 significant digits because our mass measurement only had 3. Our molar mass is 5, but that's going to limit us to 3 significant digits. Okay, so you could say 7.31 times 10 to the negative 2. You can put it in scientific notation if you wanted to, but you don't have to, as long as you can get the right number of significant figures, okay? All right, so hopefully that helps you as you're working through your dimensional analysis assessments, your 1-4 assessments in Schoology, and preparing for your VLO tests, okay? All right, so have a great day.